Hello, everyone. You are welcome to lesson 3 of the topic graphs of relation. Okay, in today's meeting, we'll be looking at how to use your graph, your drawn graphs of relation to solve equations. So by the end of our meeting, you should be able to use a drawn graph of relation to solve equations. But that will not be all. We'll be looking at questions that will not be direct. Okay, direct in the sense that you will not be giving your relation completely. Maybe there will be certain letters introduced in your relation that you'll be asked to find them before you can even graph, okay, or complete your table and graph for you to use your graph to answer, okay, the usual follow-up questions. Then in certain situations too, the graph will be provided and you will be asked to use the graph to answer follow-up questions. So today we'll be looking at all these situations and that will make us bring down the curtains on this particular topic. Okay, so quickly, let's go and look at what question 6. Remember question 6, we've done A up to what? Up to C. Now our concentration is going to be on the D, where we are asked to use the graph to find the solution set of. And you can see that I is an equation, I equally and I. So we are using the graph to solve equations. If I gave you these equations to solve, I know you can solve it, okay? But your approach will not be the graphical approach. Okay, you either use the almighty formula, the completing of squares, or the factorization method. But we also have the graphical approach, and that's what we are going to look at. So immediately you use, okay, the first three methods, factorization, completing of squares, and what do you call it? The quadratic formula. To solve this, obviously you've lost your way because you won't get it. The question strictly said explicitly that you are supposed to use your graph. So let's see how best we can use our graph to find the solution, okay, of what we have there. So quickly, let's go and look at what do you call it? Okay, D. So solution to D. So let me pick. Okay, so D. All right, so let me change the color of mine and work with the red. Okay, so D. Okay, so D, this is what you do. Please take note. Anytime you are asked to solve an equation using your graph, the first thing that you need to do is go and label your original curve, the graph or the relation that you had its graph drawn. Go and label it as equation 1. Okay, so meaning you go back here and label it as equation 1. Okay, you will have this one as your equation 1, but I am not going to, because I don't want us to move in, okay, to and fro. Okay, what I'm going to do is I will write it here. So I'll write the relation here, which is even here. So I will write y is equal to, I was given, okay, x squared minus 2x minus 5. So that's my graph. Okay, then I. Okay, which one are we given? We've been given, what equation are we supposed to solve? So let's go and pick the equation. The equation is what? S squared minus 2s minus 5 is equal to 0. So quickly, let's go and write that one too. So s squared minus 2x minus 5 is equal to 0. So this is the equation that you are asked to, okay, solve using your graph. And this is the advice. Please remember I told you your original relation, okay, must be labeled. So you label this one as equation 2. And this given equation, okay, make sure that your given equation, you have everything on one side equated to 0 before you label it. As for the original equation, okay, it will always be y is equal to something. So that one, you label it directly. But this one, before you label it, after extracting, before you label it, make sure everything is on one side, equated to 0, before you do your labeling. So this is what we are going to do. Now, fortunately for us, the equation came in that form. Everything on one side equated to 0. So I can call this equation 2. My professors, are you following?
Yes, please.
Okay, so this is what you do. Always subtract, okay, the equation that you are solving from the given relation. I repeat, subtract the equation that you are solving from the given relation. So this is what you are going to do. You can see that if you look at this relation, the relation indirectly has two sides because of the equal to. Okay, the y side and this expression side. This one too has two sides. This expression side is equal to 0. So usually where you have the expressions, so I should call it a like size, that's where you do your corresponding subtraction. So it means here I'm going to do y minus 0 because this side and this side will be a like side. This side and this side will also be alike, though they are not written in that form. Okay, maybe this you can write this one. This is the same as 0 is equal to this, so that they will obviously be, okay, in terms of size, being, okay, at the same side. But it doesn't really matter. Know that the y, okay, you always come and subtract the 0 from it. So in that case, I am going to write equation, okay, 1 minus equation 2. Okay, and that will give us y minus 0, which is y. Do you agree? Okay, is equal to, then you come and do s squared minus s squared. That will also give you 0. Minus 2x minus 2s, that will give you what? Minus 2s minus minus 2s, that will also give us 0. Minus 5 minus minus 5, that will give us what? Minus 5 plus 5, so that will give us 0. So you get y is equal to 0. Is that okay? Please, have you followed up to this point? Hello, my professors. Have you followed up to this point? Can you hear me?
Yes, please.
Okay, very good. So now this is what you do. Usually after performing your subtraction, okay, and getting your resultant equation, you are supposed to draw, okay, the line representing that relation or equation that you have there. Then where this line meets the curve, you trace and do your reading. Your readings on the x-axis will give you the solution. However, thankfully, y is equal to 0 is a special line. And what line is that? Y is equal to 0 is which line? I've mentioned this before. Y is equal to 0
So,
is which line?
x-axis.
It's the x-axis. So what you have here indirectly is the same as the x-axis. Okay, you should know. I'm just writing it. You should know. It's not necessary for you to write it. Okay, I'm writing it just for explanation purposes. So it means you are supposed to go and draw the x-axis. Where the x-axis meets your curve, okay, you trace, then you get the reason. But fortunately for you, have you not drawn the x-axis already? We have drawn the x-axis. Is that not it?
Yes, please.
Okay, so it means this line y is equal to 0 has been drawn. So where the line meets, okay, the curve, and you can see that the line, let me change the color of my marker just for identification of where it meets. Okay, so where it meets, you can see that the line meets the curve. Okay, this is the curve here. And this is the line, y is equal to 0, which is the x-axis, meets the curve here at this point, and also at this point. Do you agree? Do you agree? Oh, you are not responding today. Respond quickly and let me. If you don't agree, let me know. If you agree, please quickly let me know. We are a little bit behind time. Hello, are you with me so far?
Oh, yes, yes.
Okay, so this is where your line, okay, x-axis meets, which is the y is equal to 0 line, meets the curve. So where it meets the curve, Okay, if the line drawn was above, you trace down, you come to, if it was below the x-axis, you trace up to get the x value. But here, where it intersects, it's exactly on the x-axis. So you get the readings there. So in this case, this is what you write. You can now draw your conclusion from the graph. You can write, therefore, the question asks you to find, let me see whether it was the true set or just solve. Okay, solution set. So it means we should have underlined this. Was it a question that we were solving? No, I don't think so. We're rather solving this. Am I right? Yes, we're solving this. So we're asked to find the solution set. So it means this should have been underlined so that we'll know that our final answer must be in the true set form of the equation that we are solving. Should be in the true set form. So let's go and see. Have I lost my way? Okay, so I think this is it. Okay, so now I'll write therefore my true set. I'll get x is such that the solution will be the reading here. And that will be equal to, I'll get s equal to minus 1.5. Okay, or what's the second value? 3.5. Then I close it. Is my point well made?
Yes,
Please
please.
come again.
Okay. So I said, okay, you got it up to where we will draw. Anytime you are asked to solve, okay, an equation, I've told you what to do. Okay, make sure the equation that you are solving, everything is on one side, equated to 0. Then you subtract that from the original. Okay, you will get a resultant relation or equation. But that resultant relation or equation, you need to have its line drawn. Where that line meets the curve, then you trace to the x-axis. So the values for the x-axis, there will be the solution that you are looking for. But here, thankfully, our equation here, okay, y is equal to 0 is this line, which is already drawn. So where the line meets the curve, okay, which will be this point and this point, you trace to the x-axis. But you can see that these 2 points are already on the x-axis. Can you see that?
Yes.
So it means
Yes.
you just pick the values there. We'll come to a situation where the tracing will be very necessary. So here you just pick the values because the values are exactly on the x-axis. So that gives you the reading here, which mine is giving me minus 1.5. Okay, and the reading here, which is what, 3.5. Whatever yours gives you, okay, you write it there. Maybe minus 1.6, minus 1.4. Okay, remember, you shouldn't veer off the allowed, okay, margin of error. Okay, so now this is what we have for the solution for the I. The person who said I should come again, are you fine now?
Yes, please.
Okay, so now we go to II. Okay, what are we supposed to do? What are we already, we've labeled this one equation 1. So all that, so let's move on. What are we giving? We'll go back and pick it. Pick the equation given. So let's see the equation that we are giving. It's x squared minus 2x is equal to 5. So what do we do? I'm going to pick that one. Okay, so x squared minus 2x is equal to 5. Can I label this?
Yes, please.
Okay, you can, but you shouldn't. Remember, I told you before you label, everything should be on one side. I just said this some few seconds ago. You get it? So you don't label this one. So move. So in this case, I'll write this implies that, okay, x squared minus 2x minus 5 is equal to 0. Okay, then maybe I can label this as equation. This is the same as equation 2 anyway. So I'll label this as, to avoid conflict. Okay, because this equation is the same as this, I can label this as 2, or I can change the labeling. Is that okay?
Yes, please.
Yes.
Okay, so I am going to go for, because it's the same, I can go for 2. There wouldn't be any issue. Okay, so now this is what you do. You can see that indirectly is the same equation that you are asked to solve here. So whatever you are going to do here will be the same. So it will be equation 1 minus equation 2. Okay, so that will give us again y is equal to 0. Okay, which is the same as the x-axis. Now you are mature, so you won't write it. So what do? You go and you can now draw your conclusion because we've done that one already. So the solution will be the same as this. So x is such that x will be equal to minus 1.5 or 3.5. Then you close it. It's my point well made. So instead of giving you, say these two equations are the
Yes.
same, only that they came in different forms. So once they are the same, no matter how, okay, you put it, once they are the same, no matter the forms that they take, once they are the same, you should get the same equation. I mean, solutions. Point well made.
Yes.
Okay, then now let's go and look at what the next one, okay, which is what the I. Okay, I, what are we giving? I think that one will do a little more work. Okay, so let's see whether we will need more space for that. Okay, I will squeeze it because I don't want to move on to the next page. So let's see. Okay, what equation are we giving? We've been given s squared minus 2x minus 7 is equal to 0. So s squared minus 2x minus 7 is equal to 0. So s squared minus 2x minus 7 is equal to 0. Can you label this equation at this point? Can we?
Yes, please.
Yes, because everything is on one side. So here, I
Yes,
don't
please.
want to label this one 2 because, okay, I want to avoid, if I'm labeling this one 2, then it should be the same as this. Okay, otherwise, I will call this one equation 3. It's a different equation. Is that clear? So what do we
Yes,
do?
please.
Remember, we said we should always subtract the given equation that we are solving from the given relation. So in this case, I am going to have, this time round, I'm going to have equation, so 1 or relation 1 minus relation 3. So that gives us y minus 0. That will give us y. Is equal to s squared minus s squared. That will give us 0. Minus 2s minus 2s. That will also give us what? 0. And it will be minus 5 minus 7, which will give us plus 2. Is that clear? Hello, is my point well made?
Yes, please.
So we are going to get, okay, y minus, so it will be y, is it minus plus 2 is equal to 0. Do you agree? Do you agree?
No, please.
You don't agree. Okay, so if you said no, then it means indeed you are following. I just want to see whether you are with me. Okay, all right. So in this case, this is what you are supposed to do. So it should have been, you've done equal to the y minus that. So it means after that, the equal to is what should come. So take note of that. So at this point, I'm going to get equal to what? 2. Is that clear? So are you with me now? Hello, my professors, are you with me now?
Yes, please.
Okay,
Yes, please. Yes, please.
so now this is what we have. Remember I said, anytime you perform your subtraction, you are going to get equation of a line. And you need to draw that line. Where that line meets the curve, you trace, okay, to the x-axis, and the values there will be your solution. Because remember, the equation came in S, so it means our answers must also be in S. Okay, so at this point, what I'm going to do is I will come and write therefore. Okay, then I will have my x is such that x is equal to awaiting the result from my reading. So here you need to draw the line y is equal to 2. And you should know the line y is equal to 2 is that line that will pass through y at 2. Do you agree?
Yes, please.
So you just go and take your straight edge, then draw a line, okay, through y at 2. Okay, so that's exactly what I'm also going to do. So you can see, as you can see, okay, I'm drawing my line. Okay, and that line drawn, any line drawn, okay, must be labeled just as the curve. So this is the line y is equal to 2. Is that clear?
Yes, please.
Okay, now you can see that this line meets the curve at 2 points. Can you see?
Yes.
Okay, so let's go and locate the point once again. Okay, you locate the point with your pencil so that you can easily trace. So I am locating the first point of intersection of this line and the curve. Okay, that's the first point of intersection. The second one is this. Are you following, my professors?
Yes.
Okay, so when you can see that this your point of intersection of the line and the curve is above the x-axis, is that not it?
Yes,
So
please.
if you want to trace and get the s values, you cannot trace up, because if you trace up, you won't meet any x-axis there. So you have to trace down. Is that clear?
Yes, please.
Okay, so we are going to trace down.
Yes.
Okay, so this is what I have. So I'm also going to trace. So you should please try and follow. If you have any question, then you ask. Okay, so at this point, and remember when you are tracing, you trace with what? Broken lines. So you don't trace with a continuous line. So this will be tracing. Oops. Okay, so that will be the first one. I will come and read. The second tracing will be here where they intersect. Another point is here. Okay, then I will trace. My professors, I hope you are following. This one, it seems
Yes.
it has gone back a little. Okay, I want, though mine is not, but I want a better result. Okay, other than that, I'm introducing more human error. So the likelihood for me to move away from the allowed margin of error will be huge. Okay, so now I have traced. So after tracing, you trace because you want to get the reading. So remember, each small box is what? This is 2 centimeters to 1 unit. So each small box is what?
0.1.
0.1. So it means I'm going to get, this will be 1.5, 1.6, 1.7, maybe 1.8. So that's going to give me negative 1.8. Or I go to this reading, 0.1, 0.2, okay, this 0.1, 0.2, 0.3, 0.4. Oh, sorry, I'm reading here. Forgive me. So it's supposed to be here. So that will give me, okay, maybe 3.9. Can you see that?
Yes.
Okay, so that will give me 3.9. Then I close it. So this will be my solution. Okay, and because it's graph, it will usually give you the approximated solution, not the exact solution. Is my point well made? Are we fine?
Yes, please.
Any questions at this point before we move on to the next one?
Please come again on how you got 3.9.
Okay, so you read. Okay, how we trace that one, you get it, is that not it? Where the line meets the curve. Okay, so you've drawn your line, y is equal to 2. This line must always be drawn, because if you don't draw it, okay, you wouldn't know where it intersects for you to read. So you draw it, it intersects the curve. Okay, and it intersects the curve at these 2 points that we were able to locate. You trace down to the x-axis because your final answers must be s value. So you trace down where it meets, you trace down. So when you trace down, you have calibrated. So you know, okay, you know the size of each small box. And we said that the size of each small box, okay, would be, because the scale is 2 centimeters to 1 unit, each small box will be 0.1. So that this will be 0.5, then 1. You get it? So it means from here, I'm left with just a small box to get to 4. So I have to subtract 0.1, okay, from 4, and that will give me the 3.9.
Please, I can't see the arrow.
You can see the arrow. Okay, so you mean this. Can you see now? Okay, so
Yes.
this is the point we trace. The point that you have here, I'm looking at it to be maybe a small box away from 4. Can you see that?
Yes, please.
So if each small box is 0.1, then I have a small box away, so it will be 4 minus 0.1, which will give me 3.9. Is it clear
Okay.
now? Or
Yes,
better
please.
still, you can read 0.1, 0.2, 0.3. Midway will be 0.5, 3.5, 3.6, 3.7, 3.8, 3.9. Is that clear?
Yes, yes, please.
Okay, very good. All right.
Thank
So
you.
now you are welcome. You can move on to the next question. Okay, so with this question too, we are interested is in only the D. Only the D. Please take notes. Only the D. Okay, so quickly as usual, we will need the relation because we will subtract all given equations from the relation. So let's go and, okay, there is another way, okay, but obviously the manipulation way, okay, I think this one will be ideal because of time. That's why I'm teaching you this. So when you go back to your schools, the various schools, and your teacher add that one, then you'll be fine because usually you will not be told which of the ways to use. It will always be open. But this will be the convenient way to go because you know how to subtract one relation from another. So, okay, in this case, let's go and extract our relation. The relation is 3 minus 2x minus s squared. So I'm looking at a solution to the same question. So I'm looking at D. Okay, I have y is equal to, it is even here, 3 minus 2x, okay, minus x squared. So this is what you label as 1. By then, you wouldn't extract it here. You know that you have extracted it up here already in your solution for the AN. So that's where you will do your labeling, okay, if possible. Otherwise, you can also write it again, then you label. No issues about that, like the way I have done it. Is that clear? Okay, so now let's go and pick our I. Okay, so I. What is the equation given? So we are given, let me see if you can pick the equation. It's the same 3 minus 2x minus x, okay, equal to 0. So it's the same. So 3 minus 2x minus x squared equal to 0. So thankfully, okay, everything is on one side equated to 0. So I can label this as my equation 2. Then I will subtract this from the first one. So that will give me equation 1 minus equation 2. Okay, will give me, okay, y minus 0, and that will give me y. Is equal to 3 minus 3, that will go. Minus 2s minus 2x. Okay, that will also go. Minus s squared minus s squared. That will also go. So I will get is equal to 0. Is that clear? Hello, is that clear?
Please come again.
Okay, so you just subtract one equation from the other. So equation 1 minus equation 2, and you subtract the 0 from the y, and you subtract the side from this side, the one that contains the variables, okay, terms. So so it will be y minus this 0. Y minus 0 is 0, and equal to will come. 3 minus 3 will give you 0. You don't write this minus. So you can see that it's the same expression minus the same expression, so that will give you 0. You get it?
Yes, please.
Okay, so which is again the same as the x-axis. I won't write it. So we need to, after subtraction, you always get a equation of a line. So that line must be drawn. Where that line meets the curve, then you take, okay, your reading as what the solution. So in this case, y is equal to 0, x-axis is already drawn. So where the x-axis meets the curve, okay, so this is your curve. Let me use this. I think the other, if I do that, you don't see. This is your curve. Okay, and this is the x-axis. They will meet at these 2 points. Okay, at this point, and at this point. And I've said you will use pencil to, okay, just the tip of your pencil to locate, okay, that point of intersection. Okay. So now where they meet, okay, who can tell me? So at this point, I know I've been able to determine where they meet. So I can draw my conclusion. Let me see whether I was asked to solve or find a solution set before I draw the wrong conclusion. So you can see that here you were asked to just find the values. So you don't draw your conclusion in the two sets. Is that clear? So you have to pay particular attention to detail. So in this case, I'll write therefore x is equal to, okay, no s is said that, no curly brackets. So the first reading here, the s value will be -3. Or the second reading, the s value will be 1. All correct?
Yes, please.
Okay, so that will be it for the I. We are moving on to II. Okay, so II, we need to extract the given equation that we need to solve. So let's go back to the question. Okay, 9 minus 2x minus s squared is equal to 0. Okay, so we will extract that. 9 minus 2x, let me write the 9 well, minus x squared is equal to 0. So this one is different from this. And everything is on one side equated to 0 as well. So you can label this one as equation 3. All correct? So again, you are going to look at
Yes.
your given relation minus the equation that you are solving. So given relation, the name is 1, minus the equation, the name is 3. Okay, so comma. So we are going to get y minus 0. That will give us y is equal to, it will always be y is equal to before that. So you get y, and then you get 3 minus 9, and that will give us -6. Am I right?
Yes.
Okay, then you come to minus 2s minus minus 2s. So that will give us -2s plus 2s, 0. Okay, you won't write it. Minus s squared minus minus s squared. So minus s squared plus s squared, 0. So it means after your subtraction, the line that you had is what? Y is equal to -s. And remember, we said any line that is of the form y is equal to k is a horizontal line. I hope you agree.
Please come again.
Any line, when we did the coordinate geometry, okay, we were one comma, we said any line which is y is equal to k, it's a horizontal line. It has a gradient of 0. So that's the more reason why if you draw this line, it's going to be a horizontal line passing through y at -6. So y is equal to -6 means that line passing through y at -6. So you draw that your horizontal line, as simple as that. So take just as the other one, we had 2 also. Okay, we had a line drawn through 2. This one is going to be through -6. So this is what we have. Okay, let me go up a little. Okay, so now come and draw down your line. So this is the line. Y is equal to -6. Draw is supposed to be a continuous line. Is the tracing line to read. That will give you your broken line. So at this point, what do? Every line drawn must be labeled. This one, the first one, is already labeled as x-axis. That's why you didn't name it. This one is not labeled. So I'll write this as the equation of the line. Y is equal to -6. You can also label it here, but because it has interfered with this, labeling it here, I realize that it would be convenient for me to label it here. That's all. It just has to be labeled. Is that clear? Where we can clearly see the label. Okay, so now we know we've drawn our line. Remember, the solution will come from where the line and the curve meet. Okay, so the line and the curve meet. This is your line, this is your curve. They have one point of intersection here and another point of intersection here. Do you agree with me?
Yes.
Okay, so now we are going to trace. Okay, so remember, because the point of intersection is below the x-axis, you have to trace up to meet the x-axis before you can get the reading. So again, let me change my, okay, so what do? I will come and, okay, trace, indicate my broken line representing the tracing. Oops. Okay, let me come. I'm coming. I selected something over there. Okay, forgive me. So you should be following as well. Oops. Okay. All right. Okay, so I think I'm good to go now. Okay, so I know I've done my first tracing. The second tracing should be here. Okay, so I will trace here as well. Oops. Okay, so I've done my second tracing. So I will now come and draw my conclusion. Therefore, okay, X is equal to, yeah, I was not asked to find the true set. So the first reading here, remember we said each small box is what? 0.1. So indirectly, it's like I have two small boxes, so it will be 0.1, 0.2. So I'm going to get minus 4.2. That is from my graph. Okay, don't tell me it's not minus 4.4. That is my graph. Okay, so okay, so the second one will be, that one is only one small box. So it's 2.1. So that will give us what? 2.1. Is that clear?
Yes.
Okay, please, are we all fine? So you can see that so far it's all about you subtracting the given equation, taking everything on one side. From the given relation, you get equation of a line, draw that resultant equation of a line. Where the line drawn meets the curve, trace. Okay, if the line drawn is above the x-axis, the point of intersection will be above the x-axis, so you trace down. If the line drawn is below the x-axis, then the point of intersection will be below the x-axis, so you trace up for the s values. Is that clear?
Yes.
Okay, so now to the last, okay, one, I. Let me see whether that's the last one. Indeed. Okay, so I is what? S squared plus 3s minus 3 is equal to 0. Okay, so let's go and do that one as well. S squared plus 3x minus 3. So giving, okay, so with this one, thankfully, again, everything is on one side. Is that not it? Equated to 0. Hello, are you with me?
Yes.
Okay, so this one, something interesting will come up. Okay, and with that, I think you should be, the explanation, if you get it, any question, you should be able to do it. So I will label this as, maybe it's different from the two equations that we have here. So I will label this as equation 4. Then I will come and have equation, always your given relation, which is 1, minus the given equation, everything on one side equated to 0, which in this case is 4. Okay, so let's subtract and see. Y minus 0 will give us y. Is that clear? And that will be equal to. Now let's come to what we have here and see what is going to happen. Okay, so now let's see. Minus x squared minus s squared. What would that give us? I'm waiting.
Zero.
Minus s squared minus s squared. I'm waiting on. Oh, you people should talk
Minus
now.
2x squared.
Minus 2s squared. Please listen. Oh, look at what we are doing. I will give you an advice very soon. Remember, all my questions are carefully selected. Okay, so that will give you minus 2s squared. Is that what you said? We are going by the approach, what we've been taught so far. So let's flow. This shouldn't be a problem at all. Let's flow. So what do you get again? Okay, so you remember you are just
minus
subtracting. So this shouldn't be a
yes,
problem.
sir.
What you've been taught. Maybe you are subtracting, so help me get what you have
Yes,
here.
sir.
Mhm.
Yes,
So
sir.
minus
Minus
2x
5
minus, so that will give you minus 5x.
minus 5x. Yes,
Mhm.
sir.
Mhm.
And 3 minus 3.
Okay, so 3 minus 3 will give you. Don't say 0. I almost had 0. 3 minus 3.
6.
It will give us 6, so plus 6. Please, are you following?
Yes,
Yes,
please.
please.
Okay. And
Yes,
if you remember, I told you point blank, okay, that anytime you subtract, your given relation should be, okay, or your resultant, okay, relation should be that of a line. True or false?
True.
Okay, now after
true.
subtracting, what we have there, is it a line?
No.
No.
Yes.
You can see no. So look at this situation carefully. No. The answer is obviously no. And take note of this. Okay, if we were very smart and from the beginning, I didn't say so, if we were very smart from the beginning, so this is an exception. Please take note, I'm giving you additional advice. Before you perform your subtraction, check, okay, because if this will be quadratic, your resultant relation will be quadratic or not will depend on the quadratic term. So if I look at this equation, the quadratic term, the coefficient here is 1. Look at the equation here, the relation here, the quadratic term, its coefficient is what? Each coefficient is what? -1. And let's go back and check all the ones that we have solved. Okay, even from here, let me look at this. With this one, we were comfortably able to subtract to get a resultant linear equation because the coefficient of s squared here is negative, just as the coefficient in the relation, the s squared in the relation is negative. So you can perform the subtraction straight away. Are you listening? Remember, I always tell you, okay, the young will know the rules, okay, by the elderly and the wise will know the exceptions. So I'm making you wiser. So please take note of the exceptions. So don't straight away go and subtract. Look at it whether it follows the exceptions before you subtract directly. Is that clear?
Yes, sir.
Okay, so now, if you look at the second one to the the coefficient of s squared is negative, just as the relation its coefficient of s squared is negative. So that one, you can perform the subtraction straight away, provided everything is on one side equated to 0. Is that clear?
Yes, sir.
Okay, so here we had to go through this for you to appreciate, because if I have said it, okay, mentally, some of you wouldn't appreciate that this is what we are supposed to get. Okay, so at this point, we know anytime you want to subtract directly, make sure the coefficient of the s squared, okay, in the equation that you are solving is the same as the coefficient of the s squared in the relation. Is that clear? So it means here at this point, I will not and you should not, okay, label this equation and come and subtract, because the coefficient of this one is -1, the coefficient of this one is +1. However, we can make the coefficient here. As for this one, we can't change it because that's the relation, that's the graph. If you change it, it's going to give us a different graph. So it is this one that you can manipulate, the given equation that you manipulate. Is that clear?
Yes.
So if you want to make the coefficient of this one -1, what do we do? how do we make the coefficient of this one -1? Hello, my professors. If you have 1 and you want to make it -1, what do you do? Oh, we shouldn't waste time on this. Answer before I take your professor titles from you. If you have x and you want to make it -x, what do you do? Hey, are you with me?
Divide. Yes, yes.
You divide by x. Is that what I heard?
No, no, please.
You divide, I heard divide, but I didn't hear the rest. So I'm compelling you to continue. Or you just multiply it
Divide
by
by
multiply it by -1.
Yes,
And because there's an equation, whatever you do to each term, you have to do it to all the terms. Exactly, to keep the equal to sign.
yes.
Okay, so now we are going to go back and do the needful. Now that we know the exceptions. Is that clear? Okay, so
Yes, sir.
quickly, let's go and do the needful. So here we won't straight away, okay, because coefficient of s squared here is -1. What I'm dealing with is what do you call it? A +1. Someone can choose to say that multiply through by -1. Another person can say that move everything to this side, because if you move, you are going to get negative, this to be -s squared. It's the same thing, is that not it? Okay, so
Yes,
irrespective of whatever you do, okay, assuming I am moving everything to the side to make it negative. So if that's the case, then I'm going to get what? Okay, I'm moving. Let me see which one will be positive. Okay, if I move, the 3 will be positive. So I want to write the 3 first. Is that clear? It doesn't really matter though. When you are doing your subtraction, it will still, okay, be relevant. So, okay, so now what do we do? I'm going to get, this implies that, okay, I move 3 minus, okay, 3x, okay, minus s squared is equal to 0. Is that clear?
okay.
Is that clear? Okay, so now, obviously, this one, okay, different from 2 and 3. So I will call this equation 4. So it's now that I can comfortably, because the coefficient of s squared here is the same as coefficient of s squared here. So now I will come and write equation 1, okay, minus equation 4. So now comfortably, let's go and do our subtraction. We'll get y minus 0, which is y, is equal to, then you get what? 3 minus 3, that will give you 3 minus 3 will give us 0. Okay, then you get minus 2x, okay, minus 3s. So that will give us minus 2s plus what? X. Am I right? Plus 3s, which will give you x, I should say. Is that clear? So I'll write x here. All correct.
Yes.
Okay, then you get minus s squared.
Please come again.
Okay, so you are going to get minus 2x, okay, minus 3s. So minus 2s plus 3s will give you what? If you can't do it mentally, you just write it. It is minus 2x. What you are doing, you are doing minus 2x minus, okay, 3x, which will give you plus 3x. So that will give you x. Is that clear? We are subtracting, remember, we know the order. Okay, we are subtracting this one from this, and you only subtract like terms. So this constant will subtract, the linear terms will subtract, and the quadratic term will also subtract. So this will give you minus s squared minus s squared, and that will give you 0. Equal to be minus s squared plus s squared. Is that clear? So that one, you don't write it. Is my point well made?
Please, I still don't understand.
You still don't understand?
Please.
Oh, we've been doing a lot of subtractions. So assuming what we have here, did you understand how we got the y is equal to -6 here?
Please, I can't see your point.
Okay, did you understand how we got the -6 here?
Yes, please, I understood that one.
Okay, so it's the same thing. We are subtracting, which equation are you sub? This is equation 4. You are subtracting it from this. So remember we said it will always be y minus a 0. Is that clear?
Yes, please.
Which will give us y. Then you come to this side, which is the same as this side. So it will be 3 minus 3. And that what will that give you?
0.
Okay, so minus 2x minus 3s because you subtract like terms. Minus 2s and the minus 3s here. Only that you are subtracting this one from this. So it's minus 2s minus 3x, which will give you you are solving a math question and you see this minus 2x minus, okay, minus 3x. What will you do? Walali, what will you do?
Please, I'm coming.
No, this one you don't have to come. This one there is basic algebra, Walali. Okay, minus x minus x. What would that give you? Algebraic expressions, how to combine like terms. You combine their coefficients and you keep your, so if you have, okay, so you have 2s plus 3s, what will you write?
This you said
2s plus 3x will give you what?
5x.
So you combine the coefficients. So if I give you -1 minus -1, what would that give you? Minus minus will give you what?
Positive.
Positive. So it will be -1 plus 1, which will give you. Oh, -1 plus 1.
Zero.
It will give you 0. It shouldn't have taken you this long. If it takes you this long, then it means you are using your calculator. That's what you are telling me. So you were punching. True or false?
False.
Then it shouldn't take you this long. So in the same way, it will be minus minus will give you plus. So you get minus 2x plus 3x. So you combine the coefficients to be minus 2 plus 3, which will give you 1. So it will be 1x. But you don't write the 1 there, simply understood to be there. So it will be x. Is that clear? So that gave us the s that you have there. Then after that, you come and do, what do you call it? The minus s squared minus s squared, which will give you also 0. So you don't write it. It's simply understood to be there. So unlike the, okay, questions that we've solved so far, you remember after subtracting, you get y is equal to a constant. This gives us y is equal to 0, which is a constant. Y is equal to -6, which is a constant. But this time around, you can see that we have y is equal to what? X. Is this a constant? No, it's a variable.
Yes.
Okay, so once this is a variable, okay, it means you are going to do a little more work. You can't draw the line y is equal to x straight away. Okay, remember I told you if you are drawing a line, how many points do you need? Ordinarily, if you 2 points, and I said maybe a third one, okay, as a guide. So the other one, where y is equal to a constant, that one is a special line. So every special line, you don't need 2 points to draw. Okay, I'm talking about where it is horizontal, it's vertical. It will always pass through one value. So you draw your line to pass through that value. If its S is equal to, then it means, remember, the axis of symmetry, okay, it was passing through one value. So in this case, the axis of symmetry will pass through this line. Okay, so it will be here. So that will be a special line. S is equal to, okay, -1. Okay, that's your axis of symmetry. And that is a vertical line. Y is equal to is always a horizontal line. But here, y is equal to a constant is a horizontal line. I have y is equal to x. And please listen and listen carefully. When you have this situation, okay, go and pick the extreme values, okay, for your x in the table to predict the y, because you need two values. So this is what you come and do. You can't straight away draw this line. You need 2 points. So you go for, if x is equal to, go to the table, your first x value, and I think that was -5. Is that clear? I can equally get it from here because it's a table that I used to draw. So my first x value here will be here, -5. So I'll go for, if x is equal to -5, y will be equal to -5. Do you agree? Because this will be replaced by -5. So it means I have 1 point, which is what? -5, -5 to draw my line. 1 point to help me draw the line. Y is equal to, then go for the other extreme value for your x, the other value. And the x here ended at, I think 6, or no, 3. It ends at 3. From the table, you can get it if you can't get it from here. Let's go to the table. It's from -5 towards 3. So I'm going to use this one to predict the other value. I hope you are following.
Yes, please.
Yes, please.
Okay, so the other value is 3. So if x is equal to 3, y will be equal to what? Will be 3. Remember, y is equal to x. So if you know x, you know y. So the other possible value would be what? 3. Okay, then what? 3. So you come to your graph. Indicate these 2 points. And that's what will help you draw. So we said -5, -5. So -5, -5 is going to be somewhere here. I indicate. Usually what I do is to indicate it differently from, okay, the point that I use to draw my curve. So remember I told you, you can indicate points by using this or the circle dot. So I will use the circle dot this time around, just to distinguish between, okay, my curve point and the one that I'm going to draw. So I will use circle dots. Okay, that is -5, -5. And the other one gave me 3, 3. So 3, +3 will be somewhere here. So +3, so circle dot. That doesn't mean you cannot use, okay, you can. Okay, you can use the asterisk, or sorry, the cross as well. So now we go and draw our line. So this is it. You know the 2 points that your line passes through. So fix these 2 points and draw your line to pass through. And that will be the line that you are looking for. I hope you are following.
Yes,
Yes,
please.
please.
Okay, so now I'm going to draw my line. Okay, I don't have to go beyond, okay, my extreme values. So I've drawn the line. Remember, every line drawn must be named. So this will be the line y is equal to x. Is that clear? But unfortunately,
Yes,
that is not all. Okay, we said where this line meets the curve, okay, that is what will help you trace to get the value. So I need to locate the points of intersection of the line and the curve. One is here, and the other is here. Do you agree with me? So I will trace
yes,
up.
please.
I'm going to trace up here because this point of intersection is below. Okay, the x axis, so I have to trace up to get my s value. Okay, so I'm going to trace my broken line. Oops, I should change it to red. Okay, so oops. Okay, and the other one. So indirectly, let me see if I can come and squeeze. Okay, I don't want to go to the next page. So I just want to be a little smart and see if I can squeeze. Okay, I'm coming, give me. Okay. So I want to push this one up a little. Okay, but I hope you are following.
Yes.
Okay, so now it doesn't want to move. Okay, you let me move it up a little. Hey, let me check whether I'm recording, because at a point I paused. No, I'm recording. Okay. Okay, so I think by now you should have your readings. I think I have room. The room there will be okay now. Okay, so let's go and write. So I can now write therefore I was asked to find only S. So therefore, okay, X will be equal to, I've drawn my line. So the first reading, I will count for its value. The second reading is here. I will trace down. So this one will be this tracing, just trace down here. So that will give us, the first reading is what? You always start your reading from here. So the value here is what? So each small box, so I have 3 boxes away from 4. So that will give me minus 3.7. So minus 3.7. Okay, or then I come here, if I come here, okay, if I come here, I have 2 boxes away from, okay, 1. So that will give me, okay, 0.8. Is that clear? Okay, as for the reading, you have done your calibration. So you should determine the size of each small box. And remember, we said it will be, okay, the gap here, which you said is 2 units. Okay, so it's 1 unit, okay, divided by the number of boxes. So it will be 1/10, which is 0.1. Okay, so if the gap here is 2, so here it will be 2/10. And whatever that is, it should be 0.2. So take note for the size of small box, each small box. So that will be it for the solution of this one. Is my point well made? So immediately, here the point is immediately you do your subtraction, okay, and you don't get y to be a constant. Y is a variable, but that variable is linear. It means you have to go and fix points, 2 points, using the extreme values of your x to predict the corresponding y coordinates. Okay, because it means indirectly you know the S coordinate, 2 of them, which you get it from the table, the string values. And every S coordinate will give you Y coordinates. So you come and use the S to predict a Y, and that will give you 1 point. The second one, okay, to predict another point. Go and indicate the 2 point and join. That will give you the line that you are looking for. Where this line meets, okay, you trace, and that gives you your answer. All correct. It's my
Yes,
points
please.
were made. Okay, great. All right, so that will be it for, okay, questions of this sort. So let me see our next question on the line. Okay, so this is it. Okay, equally, I think this one was the assignment, which you were, so maybe definitely I will ask you to do this. Okay, because you've already drawn the diagram for this. Okay, so I will ask you to do this, or maybe an entirely different question. Okay, now I think we can go and have our water break. Okay, we've gone beyond 1 hour. When you come back, okay, then we'll see what lies ahead. Okay, so you are welcome back from the water break. So now we know how to use, okay, the graph, any drawn quadratic curve, okay, to find the solution of any given quadratic equation. Okay, so the next concept that we are going to learn is not entirely different from what we are doing. Only that these questions that we'll be looking at, okay, the relations will not be given completely, meaning you wouldn't know the exact relation. The relation will involve letters. Okay, letters, constants, either your coefficient of s squared, the coefficient of s, or your constant term. Okay, not all of them given. And as you can see, in the table below, you are given y is this. Okay, so what are we supposed to do? We need to okay, AI, use the table to find the values of P and Q. And I, copy and complete the table. And I can assure you, if you are not able to find P and Q, there is no way you can do the I, and therefore do the rest. And if your P, Q, any of them is wrong, it means obviously the rest will be what's wrong, because you'll be dealing with the wrong relation and therefore the wrong table, therefore the wrong plot, the wrong graph, and what have you. Is my point well made?
Yes, please.
Okay, so this is all that we need to do. Just one or two information that you need. Okay, this relation contains how many unknowns? How many unknowns?
2 unknowns.
Which will be P and Q. And if you have an equation involving 2 unknowns, how many equations at least are you supposed to generate before you can find these 2 unknowns?
So
2, exactly. So here you need to generate 2 equations that you will solve simultaneously, that's all. And once you know one x and you know its corresponding y, you can come and substitute. If s is known and y is known, your resultant equation will be in terms of only p and q. Is my point well made? So that's all that we are going to do here. After that, the rest will be what? Trivial. Okay, so quickly, let's go and have a look at how best you can present your solution, since that's also what counts. Okay, so now we go to the solution. So we have what? 9. Oh, that's not yet. I think I saw question number 9. Yes, question number 9. Okay, we need to extract what we are giving. So we are giving, okay, though what we are giving is not the exact relation, that is what we are giving. So we should extract that. And that is PS squared minus 5S, okay, plus Q. So equally, okay, PS squared minus 5x, okay, plus Q. Am I right? Okay, so that's what we are giving. Okay, so now, okay, we need to find the values of P and Q before we can complete. So you've drawn your table, you know, let me see. The table will come after, so it means I have to move the table. Okay, just a letter. Oops. Okay, I have to move it to a point. I will position it well. So let me normal accordingly. So what I'm going to do is what? Okay, I need to find the values of P and Q. So by then, okay, I will know exactly what to do. Because I want my copy and complete the table to take the position for II. That's why I am doing that. So now let's go to exactly what we were doing. So in this case, you know, okay, so I can write but, okay, or you can write, this implies that, come and take. And my advice is, okay, please check whether from the table, you know, okay, or use the 0 for the x and its corresponding value. Or if in the table for the y, you see 0 there, use the y and its corresponding s value. Okay, use it, because here you can use minus 3 and 21, minus 2 and 6 as well. You can use any of these numbers. I'm saying that if your numbers that you are going to substitute, be it x or y, if any of them is 0, it will make your work very easy. So go for those ones. So here, if 0, its corresponding number, value for y was not known, then it means you can't use. Okay, you can use the 0 here because its corresponding y is what known. And same for this one. So instead of picking maybe the first 2, I will, for convenience sake, go for this and that, then this and this. Sorry, the 4 and the 0. Take note. So I am going to, okay, look at this from this way. So I can say that, or let me even go back and write, this implies. Okay, now if my x is 0, I'm going to get p into 0 squared. Okay, so it's y is equal to, okay, I forgot to write the y. So it doesn't really matter. You can write it here. Don't cancel it. It's the same thing. Oops. Okay, I want to do something here. I'll come and redeem myself here. So it's equal to y. So now you get, okay, y, which is what? We are using this. So y is negative 12. Okay, it's equal to p into x squared. X is what? The corresponding value for x is what? 0 squared. Then minus what? 5 into your x is 0. Then plus q. Okay, so I'm going to get minus 12 is equal to, this will give me 0. The whole of this will go. This will also go. So I will get q to be equal to minus 12. Is that clear?
Yes.
So I know q. Okay, so now I'm going to pick the other one. So and, okay, I'm going to use this and this. Y is 0, so I'll get 0 will be equal to, okay, p into my x is 4, so 4. Okay, then, okay, minus 5, my x is 4, so into 4. Then plus q, okay, you see, is equal to 0. That's what you have there. So now you are going to get 0 is equal to 4p, okay, minus what? 20, okay, plus q. Is my point well made?
Yes, please.
Okay, so here is the case you know q. So you go and substitute and you find that. So that will give us, this implies that, okay, 0 will be equal to 4p, okay, minus 20, then minus 12. Okay, so solve for p. Okay, I'm coming for you to give me the value of p. Okay. So you get 0 is equal to what? 4p. Minus what? Is it 32?
Yes, yes.
So you move that one, this one to the side. So in my mind, I know I'm moving this one to the side, but I'll still write this one first. It's equal to 32. So 4p is equal to, then I'll move. So that will give me my 32. Okay, I write it again before I divide. So that will give us p to be equal to. And what we are doing, I think, is I. Is that not it? So you need to label,
Yes.
okay, is it AI? I think it's AI. You have to number appropriately. Have I gone back too much? Yeah, I think so. Okay, it should be somewhere here. Okay, it's AI. So AI is what we are doing. So you have to, it should be AI. Quickly, let me do the needful. So immediately you start doing that, you should know that you are dealing with AI. Okay, all right. So P, what did you get for P? Oh, we shouldn't waste time on this. I want you to make the class interactive.
Eight.
You had what? Mm-hmm.
Eight.
Okay, so 8. Okay, so that's what you have. Okay, so you know P, you know Q. Okay, so once, so it means indirectly you know the relation. So we are now, we've not drawn our conclusion, or take note. We are now going to have our conclusion drawn. Okay, so let me move this one. So someone can come and write, therefore here, another person, I mean, therefore, but here I'm going to draw the conclusion together. So therefore P is equal to 8, and okay, Q is equal to minus 12. So if that's the case, then it means you know the actual relation. Is that not it?
Yes, please.
Okay, so it's the actual relation that you are going to use, okay, to do this. Okay, you are going to use to complete the table. So at this point, maybe you can write, when it comes to B, where you are asked to copy, and complete the table, you can write, okay, this implies that your y is equal to, then substitute the values. So that will give you 8s squared minus 5s, then minus 12. Is my point well made?
Yes.
Okay, so let me see if I can duplicate this. Then we go and do the right thing there. Okay. So now we come to AII. That's what we are looking at now. Okay, so AII. I. Okay, we now know the actual relation. So we know that y will be equal to 8x squared minus 5x, then minus 12. Okay, so let me see whether I am right. Okay, yes, minus 12, I am. Okay, so this is what you are going to use to complete the table. Then after that, you use it to draw your curve. Is that okay?
Yes, please.
Okay, I don't want us to waste time on that. Then when you draw your curve, maybe I will use another curve just because of time to explain this particular question. After drawing your curve, okay, it is this question that you need to solve. And there is nothing difficult about it. You are asked to use your graph to find y when s is equal to 1.8. So it means go and draw the line, okay, s is equal to 1.8. Okay, so I'm just assuming this is my graph. Assuming this is my graph. Okay, so x is equal to 1.8. This is 2. So 1.8 will be somewhere here. I draw my line, s is equal to 1.8. Where it meets the curve, then I, okay, get the reason as what? As my values for, okay, x. Is that clear?
Yes, ma'am.
Okay. Did I say as my values for s, as my values for y? Let me see whether you were asking x, please. Well, let me check whether you were asked x to find. Okay, find y when s is equal to 1.8. So I rather went to read on the y-axis. So find y when s is equal to 1.8. So it means it is the s value that is you are given to predict the y. So assuming this is my curve. So x is what? 1.8. So where is 1.8? 1.8 is somewhere here. Okay, then I will trace to meet the curve. Where I get the curve, then I will get the answer, okay, there. So meaning, I'm just assuming, maybe the question asks you in this situation, you were asked to find, okay, the value of y if x is equal to 3. Let me say, is it 3? As for 3, there we know. So let me use maybe 2.5, negative 2.5. So what you do is come and fix your 2.5, the negative 2.5, which is here. Negative 2.5 is here. Do you agree? Okay. So trace, this is negative 2.5, where it is. So come and trace. Where it meets the curve, go and read the y-axis. So then I come and read the y-axis value there. So I trace that one as well because I'm using that x to predict the y. Please, are you following?
Yes, sir.
Because of time, you couldn't draw the exact graph to do the analysis. The explanation that matters. When you get it, so you trace. So it means here, if x is equal to minus 2.5, y will be equal to, okay, negative 6. As simple as that. Okay, so that will be the solution. So if this was I, okay, you write therefore y is equal to negative 6. Then the other one, assuming you are given y and you are asked to predict x and the y is maybe 4.5. So assuming you are given y to be equal to 4.5, or let me even say 4.2. So you come to your graph where you have y to be equal to 4.2. 4.2 is somewhere here. Okay, please. Okay, you trace. So this is a line. Oh, sorry. This is a line that will pass through. So I come and draw my 4.2 line. Y is equal to 4.2. Okay, so where my line will meet. Where is my, okay, so 4.2 will be somewhere here. Okay, so there's the line, y is equal to 4.2. Okay, where it meets the curve. Okay, I trace and read. So I will trace and read. I will trace with my straight edge. Okay, and read and come and write the values there. As simple as that. Okay, I don't know. Okay, so I think the last concepts, okay, I'm going to quickly move to the last concept where you are given your graph and you are asked to use your graph, okay, to generate your relation whose graph you have there. So let's look at this question, which will be our last question for the day. Okay, now, okay, in this question, you can see that you are given the graph. There is no table. Okay, and your relation to, you don't know, okay, any of the constant, be it the coefficient of s squared, the coefficient of x, or the coefficient of s to the power 0, which is usually our constant c. You don't know any of them. Okay, and the question is asking you to determine the minimum value. So in this case, sorry, the maximum value of what? Y. As for this one, we know. You just have to place your straight edge here, then trace. Okay, so that will give you, okay, the I will give you y is equal to 4. Do you agree?
Yes, sir.
Okay, you don't need a relation. Once you know its graph, you can predict, okay, the maximum and the value of x. Now you are asked to find the root of the equation y is equal to. So I'm going to write here just to explain something. When you get it, okay, that is it. So I'm asked to find the root. Okay, take note. The root of any equation, okay, quadratic equation, will be given by where the curve, okay, cut the x-axis. That will give you the roots. I'm repeating, the root or the solution of every quadratic, okay, equation. Please take note of every quadratic equation by using the graphical situation or the graphical approach will be where the curve cuts the x-axis. So it's in this case, because the quadratic equation is in x, okay, if I'm asked to determine the root of this quadratic equation, I can easily determine. I have to look for where the curve meets the x-axis. So in this case, for the BII, okay, all right, therefore, okay, the root will be remember we did polynomials, especially, okay, the elective math students. We said the roots, the zeros, and the solution, they are the same, if you remember. So if you're asked to solve, if you're asked to find the root, if you're asked to find the zeros, okay, you are dealing with the same thing. So here you don't write there for the root, you just write there for x will be equal to. So come and pick the S value here, the first S value, okay, which you are taking as your point of intersection, and that will be -3. Or your second S value, which is the point of intersection here, 1. So this will be the root, okay, which is the same as the solution. Now, what are you supposed to do? He said using the root, which will be your solution, determine the values of A, B, and C. Okay, and we did this for every equation. If you are able to get its roots, its solution, its zeros, you should be able to give us the equation that gave us that result. So here for the B, this is all that you need to do. Okay, you know what you have here the same as x minus 3 is equal to 0. Sorry, is equal to 3. Forgive me. What am I saying? X, okay, this is what I want to write. X, let me go back. Okay, so this is the same as x, okay, is equal to -3 or x is equal to 1. Do you agree? But when you are writing it maturely in terms of our conclusion, that's how we write it. Don't come and write x is equal to again. It implies. So here we are going back. Remember, we did this in polynomial. So if you are going back, you move this one to this side. So that will give you x plus 3 is equal to 0. Then this will come here, x minus what? What do you call 1 is equal to 0. Remember the factor theorem, the factor property. The remainder theory, remember. So here, what you only do is what? You come and multiply these two sides and you create, so you to get x plus 3 into what? X minus, okay, 1 is equal to 0. You expand. After expansion, combine like terms and you compare. So for lack of space, let me see whether I will have a space down to continue. Okay, I think there is a solution space. So I will have a solution space here. So I'm going to get what? If I continue, remember we had x plus 3 into x minus 1 is equal to 0. So you expand, s times x will give you s squared. Okay, s times minus 1 will give you minus x. 3 times x will give you plus 3x. 3 times minus 1 minus 3 is equal to 0. So x squared, you have like terms, which will give you plus 2x minus 3 is equal to 0. So you then come and compare this one with the given relation, which is the a s squared plus b bx plus c is equal to what? Is equal to y, or y is equal to. So if you compare, a will be equal to 1, b will be equal to 2, and c will be equal to negative 3. As simple as that. So anytime you have the solution to every equation, which will be maybe s is equal to 1 or x is equal to 2, okay, you can go back and give us the equation whose root will be this. And by that, you go back. You remember the 1 was here, then you move it to this side. So you take it back, and that becomes x minus 1 is equal to 0. The 2 was here, then you move it to the side. So that will give you x minus 2 is equal to 0. And at this point, okay, you were able to solve for x because you use the zero product rule. So what do? You now come and multiply this one, these two, x minus 1, okay, x minus 2, and you get what? 0. Then you come and equate each of them to what? Okay, I mean, sorry, you expand and combine what's like terms. As simple as that. Okay, so this will be equal to 0. Is my point well made?
Yes.
Okay, so take notes. Anytime you are asked to find the roots from the graph, it is just from what you have here. There is another approach, but because we've not done quadratics, that's the more reason why I'm unable to. There's another approach which will be x squared minus, so the equation will be given by x squared minus sum of roots, okay, x plus product of roots. Okay, is equal to 0. So in that case, you get s squared minus sum of roots. What was your root? We had the roots give us what? I think minus 3 and what? And 1. So you sum. Okay, that's the other approach. Okay, so sum of roots. The root we said we had x is equal to minus 3 and x is equal to 1. So you sum, or it was the other way around. X is equal to minus 3, x is equal to 1. So it will be, if you sum, we are going to get minus 3 plus 1x, then plus the product, which will be minus 3 into positive 1 is equal to 0. So that will give us s squared. This, if you add, you are going to get what? 2x. But if you, sorry, minus 2. Okay, so it will be plus 2x. Okay, then this one, if you multiply, you get minus 3 is equal to 0. Is it not the same as the same equation that we have here?
Yes.
It's the same. Okay, but you can use, okay, this approach. This is better when you are going back rather than the formula. Okay, so
Yes.
that will be it in terms of the graphs of relation. Okay, so in fact, I'd wanted to give this one to you as your assignment. Maybe I can still give it to you to test your level of understanding for today's work. Okay, especially this one. Okay, especially this one. But in the test, take note. It is the one that you will, okay, the graph will be provided. Okay, And you are supposed to, the last one is the form that will come in the test. Okay, so please take notes. So this one, once you do an assignment on this one, prepare for the test on the other one as well. If you're able to do these two, the rest you should be able to deal with it. Okay, because those ones are direct. Where the relations are given directly, you should be able to deal with it. Okay, any questions at this point? Hello, any questions? Okay, so you get the video. Okay, then make sure you go over the video. Any outstanding issues, okay, you deal with it. Or if you think you have to call me or get back to me to explain, okay, further, okay, I'm always available. If you call me and I'm not available, I'll let you know. Okay, then we will fix time together. So at this point, thank you very much, okay, for making the lesson a success. God bless us all.